allele frequencies can change through chance events, and therefore it is considered an example of genetic drift. So this I discussed previously, so no need to clarify all these things. So just scroll. But there is one point: genetic drift can also happen even without all these. Generally, the probability of genetic drift tends to higher when population size is smaller, because if the population is this, the chance is this much, and the proportion is very less. But if the population is like this and the genetic drift is like this, so the chance can be 1:1 also. So then genetic drift is so much affecting. In practice, not always easy to determine whether a trait we see today has evolved due to selection or drift. That is, there is no specific way to define that, but we can assume if it is for genetic drift or selection by some methods which we will discuss in maybe later. Now, there is a scenario where there is a forest fire coming from this side. So the fire burns some trees, but some trees still resist the fire, so they just leave. But these trees burn because of chance event. But there is a river, so these trees don't burn, although they may have less favorable traits to resist fire, but due to chance events they didn't die. So for these things we can say they are naturally selected, natural selection happens, and for surviving of these things we can say this is genetic drift, due to genetic drift. Now, how allele frequencies can change? One is selection, another is genetic drift, and there can be gene flow too, emigration and immigration both. And for the gene flow thing, I have told you before, immigration from emigration to, sorry, emigration from immigration to. Now now we will come to histograms. So we can do these things like frequency distribution of heights, weights, or those things in a graph where we plot the trait with respect to the frequency distribution, and then we see the size of the graph, the characteristics, and we find mean, variance, and arrange these things. Now for x-axis we use fitness functions, and here we use frequency. We will use fecundity as fitness proxy here. So there are three types of selection: directional selection, stabilizing selection, and disruptive selection. Now we will see, first see that here the mean is 6. Now the fitness function tends upwards, so individuals at here having this trait are more fit to live, and they're more fit to reproduce. So what do you think? This mean will shift that word. So it may be 7, maybe 8, maybe 9. So here for practical things, we see that the mean has come to 8. Okay, so we can say this happened, this was the previous one, and now this is the later one, and these are two means. Mean has increased because the extreme higher trait value which the environment, those individuals prefer and have more fitness, and so they survive more, reproduce more, and their frequency is increased, so mean is increased. This is called directional selection. It can also come to this direction. Here is depicted with graph. Here is a practical representation of this. You can pause the video and study it. Now come to stabilizing selection. We check here the mean is 6, and let's say here the variation is 2, or we can see here at 10. Okay, at 10 the variation is 4 to 10. The variation is 6, let's say. Now fitness function is like this. That means individuals at this portion tend to live more, survive more, and reproduce more. Their fitness is more. Okay, so there is pressure from this side, pressure from this side, and the graph goes like this. So we see the now take variation at this point 10. Variation is from 6 to 8. Here it was 6 at 10. Here at 10 the variation is 2, or some nearly 2. So the variation we say is decreased. So for stabilizing selection the variation decreases. This was the previous variation, this is the new variation. The variation has decreased. Okay, this is also practical representation of this. Pause and study it. Now we come to disruptive selection. So the lowest extreme state and the highest extreme state is preferred here. So for this, here frequency is less, here frequency is less, but as these are preferred, so pressure is this side, pressure is this side, and pressure is that this way. So if it was like this, it becomes like this. So here we can say there is a probability to increase of range. Like if this is range, there is probability to increase the range, but it may not also. So if the graph is like this and it was previously like this, pressure here and pressure downwards there, later the graph should be like this. Here it is also like that. I have drawn something like this, and here it is like this. There are two peaks, there should be two peaks, and there are also two mean values. Here is the practical representation of Pyranustes austrinus. That is also that thing of big size. This is the disruptive selection graph. So this reading exercise is for the watchers. This I had also said this previously, so we can skip this. Now there is a point of thinking. If the fitness function is like this, here it is the trait is preferred more. Here the trait is preferred a little bit more. So we will interpret it like this. Here this is the pressure. Here this is the pressure, and here the pressure is smaller. Okay. So what will happen? It will be directional disruptive selection. So this will happen like this. The graph will go like this. There will be two means, but if the graph fitness function was like this instead of this, fitness function is still this much. So this is something like this. So then it would have been, the pressure would be only this side. So the selection would be like this. This is directional selection. And this is disruptive. So if we remove this part, the selection becomes directional, and if this part exists, the selection is disruptive. So this is a point of thinking. So you can visit these places to ensure your understanding. And there are also some types of selections. We will say in conclusion that there can be sexual selections, intrasexual or intersexual selection. Intrasexual, where males fight to each other for a female, and intersexual is when a female chooses a male for mating, and that's all. There is nothing much for thinking. So hope you have enjoyed this long session. So I will take no more time. So goodbye, wait for the next video.